Hey Algebra 1, this is going to be your lesson on 5.7, Systems of Linear Inequalities. You are going to get some graph paper notes handed to you to help graphing. Help with graphing. There's going to be 2 questions with graphing. The rest of them is kind of a mix of what you're going to be seeing on your homework tonight and tomorrow. So first thing we're going to write down is tell whether each ordered pair is a solution of the system of linear inequalities. Essentially, we're just going to be plugging in both the x and the y values to both inequalities to see if there's a system. This is what that looks like. So here's what I've done is I've went ahead and plugged in both my x and y values into my inequality 1 and inequality 2. And then I'm just going to determine if it makes a solution for both sets. The first one would be 5 is less than 6, and that is true. The second one would be 5 is greater than or equal to 4, and that one's also true. So we would say yes, these are a solution to both the inequalities or the system. With letter B, let's see what that looks like plugged in. So for this first one, we're going to have 0 is less than -4. And this one is automatically not true, so we would have to say no for letter B. Even if letter B over here, or the second one, 0 is greater than or equal to -1, that is true, but it needs to be both true in order to be a system. So we would have to say no for letter B. So that's exactly what you're going to try here. For number 1 and 2, you're just going to plug in both your x and y values to see if it makes a solution. If any one is not a solution, then you have to say no for that answer. Let's go ahead and pause here so you can try it on your own, and once you're done, click play. Alright, so what I'm going to do first is go ahead and plug in my x and y values for number 1. The only thing I really could plug in for this first one is the y, and since 5 is not less than 5, I have to say no for number 1 because 5 is not less than 5. So number 1's answer is no. Let's go ahead and plug in for number 2. So I have here 4 is greater than or equal to 3 times 1, that's 3, and then plus 1. That gives us 4. That is true. And then over here, 4 is greater than 1 minus 1. That would be 4 is greater than 0. That is also true, so I would say yes for my answer in number 2. Okay? The next part is actually graphing and finding a solution. So this is going to be a majority of what you see on your homework tonight. The graphing is the same type of steps that we've been seeing all throughout Chapter 5. The only difference is that where the 2 planes cross over is where you can have your solution. So here are my 2 examples that are already graphed over here. And I have a greater than or equal to, and then I have a less than. And notice there's this like purple shaded part right here. This is your solution section. So you can shade in that and provide an example from there. So I could say, for instance, a solution in this section could be -2, -2. That would be right here. -2, -2 is a possible solution because it's in the shaded portion of both regions. Okay, so you could also have many different solutions when they cross over. If they don't cross over, then there'd be no solution there for the system. Let's go ahead and take time now just to pause and write down this important information. You might not need to write down step 1 and step 2, but I would write down this stuff down here that's typed in black and bolded. So this is actually how it's going to be done. The first thing I'm going to do is graph the first example, which is y is less than or equal to 3. Sorry about that. So here's my first example that I have graphed. Y is less than or equal to 3. I found 3 on the y-axis. It's less than or equal to, so that's a solid line. And then I have to shade everything that's less than that. Now I'm going to switch over colors and graph the next one for inequality. So my y-intercept is a +2, and then my slope is 1 over 1. So my line is going to go all the way through here. And since this is a greater than, that's going to be dotted. And so basically everything that's bigger than that would be up here. And notice I do have some crossover. So essentially, and I'm going to kind of erase what is crossing over, I can use this portion. So it probably would be helpful on your homework to only show the crossover amount, or just make sure you're using 2 different colors if you can. So an example solution Could be anything in this region. So I could maybe say that my example solution is -3, so 1, 2, 3, +2, which would be right in this region. So -3, +2. So what you're essentially doing is just showing the crossover for that, and that's exactly what you're going to do next on that provided piece of graph paper. So here is number 4. This should be the one of the questions on your graph paper. Let's go ahead and try this. Notice that they're not in slope-intercept form, so you will need to write it in the y is less than or equal to or greater than or equal to mx plus b form. Okay, so let's go ahead and pause for number 4, try it, and once you're done, click play once you have your sections shaded with that crossover region. So what I'm doing first is just writing in y is equal to mx plus b form. So I'm just getting y all by itself. So I get y is less than or equal to -1/2 x minus 3. And I'm going to go ahead and graph inequality 1, and this is going to be the red graph. So here's my line. It is solid line because it's less than or equal to. And so I'm going to shade everything that is less than or equal to first. I am going to use 2 different colors so you can kind of see the difference here. The next one I'm going to go and write in y is equal to mx plus b form. So here's my inequality. Y is less than 2x plus 2. So I'm going to just go up to +2 on the y-axis. And then my slope is rise 2, run 1. And then I do have to go down here too so I can get some intersection. If you notice that none of your planes are going to intersect, then obviously you would say no solution. This one is less than, so it'll be a dotted line. This one might be a little overkill for yours, but notice my it's going to be less than, so all of my crossover will be in this region right here. So if you wanted to, you could go back and erase the excess from your first line. Okay, and that one would have an example. Maybe we could say for this one, anything, I would maybe say -2, 1, 2, 3, 4, -4 would be an example solution. Okay, but obviously all you need to do really is provide the shaded region. Okay, so we're going to try another graph one, and then we'll finish up with 2 really simple ones. So let's go ahead and try number 5. Again, let's pause. This is the last one on your graph paper, and then we'll talk about 6 and 7 once we're done here. So with number 5, the first one's pretty easy. It just says x is greater than -2. So that one just means I find -2 on the x-axis. Go ahead and provide my dotted line. And then shade everything that is greater than, so everything to the right. So all of this stuff right here. Okay. And then the next one I will have to write in slope-intercept form, so I'm going to go ahead and do that in a different color. So here's my equation. Y is less than 1/2 x minus 1. So that's -1 on the y-axis. And then rise 1, run 2. Rise 1, run 2. Obviously you don't want to shade too much so that you can still find your intersecting points. Okay, and this one's dotted and less than or equal to, so you can already tell where your intersection should be. It should be this section right here. So again, if you want to go back and erase, you can. A lot of times too, what might be easier, so say for instance we started with the purple graph, I would maybe just make some points over here that I know I'm supposed to be shading this way, and that way you know where your intersection could be. That could be something else too. An example solution, I could say maybe my solution could be 1, -2. So that's just an example, but again, you just want to provide your shaded region there. The last thing we're going to write in our notes is how to just write the system of linear inequalities represented by the graph. So this one, you'll essentially look at the graph and write your system using the less than and greater than signs, depending on your lines, and then go ahead and check your work once you're done. So let's go ahead and pause here. You should write 2 systems. Okay. So for the first one, I'm going to say y. On the y-axis, we have a -2, and it is shading up, so that is greater than or equal to -2. The next one, I can still put in slope-intercept form. So y, and this one looks like it's being shaded down, and no solid line, so that would be less than. And then I noticed that my slope-intercept is 0, so I could say plus 0. And then my y-intercept is 0, but then my slope is rise 1, run 1, because that's every single time it's intersecting. So what I would say is 1 over 1x, or just 1x, or you can simply write y is less than x. So I'd actually maybe stick with these two right here. Okay, let's go ahead and try the last one in your notes. Again, writing the system of linear inequalities. Let's go ahead and pause so you can try by yourself, and then once you're done, click play. So for this one, we have an x value, x, and then it is a less than or equal to graph because this is a solid line and it's graphing everything to the left, and then it's at the number 3. So we'll say the first one is x is less than or equal to 3. For the next one, it is a linear system, so we will write it in slope-intercept form. It does a dotted line and it's shaded up, so that would be greater than. The slope-intercept is, the y-intercept is -1. And then you have to count your rise over run to get your slope. So we would rise 1, see if I get this to work here, 1, 2, and then run 1, 2, 3. So that'd be 2 over 3x minus 1. So y is greater than 2/3 x minus 1. And that would be your two systems of linear inequalities there. That's going to be all for lesson 5.7. Thanks so much for tuning in, and we'll catch you next time.